Greetings everyone, and today we are going to discuss about factors affecting the bond energy. So first, let us discuss about the major factor, which is a polarity. Polarity is a factor. First, let us discuss what is it. Polarity is basically the formation of poles. It is the molecules having poles, charges, having two opposite poles, charges within the molecule of an atom, presence or the existence of two opposite poles within an atom of the molecule. In this case, how we can define polarity? For suppose we have hydrogen. Hydrogen is having a single bond with fluorine. Now here we know that hydrogen is having its electronegativity as 2.1, whereas fluorine is having its electronegativity as 4, due to which we know that electronegativity is the capability of an atom to attract the bond pair, capability of an atom to attract the bond pair. Here the electronegativity of fluorine is higher, due to which fluorine will tend to attract the bond pair of the electron more towards it rather than hydrogen. Why? Because fluorine is having higher electronegativity, it will attract the electron towards itself, due to which fluorine getting the negative charge, hydrogen getting the positive charge, because electron pair is slightly towards the fluorine because of high electronegativity. Hence, fluorine becomes slightly negative, hydrogen becomes slightly positive. Now, we can say that here the positive and negative charge are having differences. These positive and negative charges are having differences. These are opposite charges. These are opposite charges, due to which the presence of charges tends to create a force of attraction. As the force of attraction is present, force of attraction causes to strengthen the bond. As the bond is strengthened, there is high amount of bond energy required to break the bond. So this is a concept of polarity, that if polarity is present, there is higher bond energy. How we can prove it? For suppose we are having hydrogen and fluorine. The electronegativity difference of hydrogen and fluorine is 1.9. When it comes to hydrogen and chlorine, for suppose if there is hydrogen and chlorine electronegative difference would be 0 0.9. For suppose it is 0 0.9. Here hydrogen is having 2.1 and chlorine is having 3, so it will ultimately become as 0 0.9. 0.9. Now this is how we do it. So here, as you can see, chlorine and hydrogen is having lower electronegativity difference, and hydrogen fluoride is having higher electronegativity difference, due to which if there is higher electronegativity difference, more polarity in hydrogen fluoride, it is having more bonding energy as compared to hydrogen chlorine, because hydrogen chlorine is having 530, hydrogen chlorine is having 431 kilojoule per mole as its bond energy, and hydrogen fluoride is having 523 kilojoule per mole as its bond energy. 523 kilojoule per mole as its bond energy, and HCl is having 431 kilojoule per mole as its energy. Now coming to bond length is the is the length of a is the distance between the two nuclei of the bonded atoms joining the covalent bond. In this case, bond length, if we know that as we know that if bond length is increased, if the bond length is increased, internuclear distance between the two atoms is increased. As internuclear distance is increased, that causes to decrease the forces of attraction from the nucleus on the valence electron. As the forces of attraction are reduced from the nucleus to the valence electron, that causes to form a weaker bond. Due to which less amount of bond energy is required. So we can say that here bond length is inversely proportional to bond energy. Bond energy is inversely proportional to bond length. Example of this is fluorine. For suppose we are having fluorine and fluorine, and hydrogen and hydrogen. Here in this case, uh, fluorine and fluorine is having high bond length, but even though it is having high amount of electronegativity, high amount of bond energy, because there is an exception over here, that there is a condition that here, even though fluorine is having high amount of electronegativity difference, high amount of size, it is having less electronegativity. It is having high bond length, but it is still having high bond energy. So this is an exception. Let's discuss another example here. For suppose we are having um, carbon to carbon, carbon to carbon double bond, and carbon to carbon single bond, carbon to carbon double bond, carbon to carbon single bond. So suppose this is carbon to carbon double bond. Carbon to carbon double bond is having its bond length is higher. Double bond is having double bond. We know that whenever there is a bond order is increased, if the bond order is increased, multiple bonds are formed. The forces of attraction has increased. As forces of attraction are increased, the bond length is decreased. As the bond length is decreased, it causes to increase the bond energy. So in this case, a carbon to carbon double bond is having less bond length, which is around 1.38, which is around 1.38 angstrom, 1.38 angstrom. And carbon to carbon single bond is around 1.57, something like it, 1.57 angstrom. Now in this case, bond length of carbon to carbon is more because it is having high amount of bond because it is having high amount of bond length, so it is having less bond energy. It is having high amount of bond energy because it is having less bond length, so it is inversely proportional. Now size of atom, size of atoms, if the size of atom is increased, the bond energy is decreased. How? Because fluorine and fluorine are there. Let's suppose fluorine and fluorine, fluorine high high atomic size is there. As there is high atomic size, there is less internuclear force. As there is less internuclear distance, high there is more internuclear distance, less internuclear force, due to which there is high uh, amount of chances to make weaker bond, which means weaker bond is formed. And as there is weaker bond is formed, that is having less bonding energy as compared to hydrogen. Hydrogen is having less size of atom, more nuclear force attraction is there, more internuclear force is there, due to which stronger bond is there, high bonding energy is there. And after that, bond order, when it comes to the bond order, if bond order, we know that bond order is directly proportional to bond energy, because multiple bonds are there, more forces of attraction is there, and thus bond order is increased. That's all about this video. Hopefully we'll meet again in another